Hello everyone, this is Dr. Sumit Chauhan and today we'll discuss data link layer, and in data link layer we have data link control and protocols. The learning objectives of this video are to introduce the protocols for error and flow control, to discuss stop and wait, go back and selective repeat ARQ, to discuss concept of piggybacking and pipelining, and to discuss SDLC protocol and its various frames. Flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for the acknowledgement. Error control in the data link layer is based on automatic repeat request, which is the retransmission of data. Error control techniques: when an error is detected in a message, the receiver sends a request to the transmitter to retransmit the ill-fated message or packet. The most popular retransmission scheme is called as ARR, automatic repeat request, that is ARQ. Such schemes where receiver asks transmitter to retransmit if it detects an error are known as reverse error correction techniques. So in error control we have two stop and wait ARQ and sliding window ARQ, and in sliding window ARQ we have go back and selective repeat protocols. This is normal operations when sender first of all send frame 0 and it receives an acknowledgement from the receiver, and after receiving the acknowledgement it sends the next packet, and when it receives the acknowledgement of that packet then it will gonna send the third one. Now in stop and wait ARQ, which is simplest among all protocols, the sender, say station A, transmit a frame and then waits for the acknowledgement, positive acknowledgement or negative acknowledgement from the receiver, say station B. Station B sends an acknowledgement if the frame is received correctly, otherwise it sends a negative acknowledgement. Station A sends a new frame after receiving acknowledgement, otherwise it retransmits the old frame if it receives a negative acknowledgement. Now this is a diagram: stop and wait ARQ and a lost frame. So sender sends frame 0, gets an acknowledgement, then S1 and this frame 1 get lost in between the link, in between over the link. So the sender will wait for an acknowledgement for a specific period of time, and if it won't get it back, it will again resend it with the same number. Now here we have, if you lost the acknowledgement, not the frame, so in that case even the sender will gonna repeat the frame of which the sender didn't receive the acknowledgement. In stop and wait ARQ, numbering frames prevents the retaining of duplicate frames. This is stop and wait with delayed acknowledgement. Numbered acknowledgements are needed if an acknowledgement is delayed and the next frame is lost. Now this is the concept of piggybacking, that not sending the acknowledgement separately, just waiting for another frame that has to be sent and just attaching that acknowledgement of the received frame along with the new frame that has to be sent by the receiver. Now here we have the definition of piggybacking and what is its advantage. The link between receiver and transmitter is full duplex, and usually both transmitter and receiver station sends data to each over. So instead of sending separate acknowledgement packets of the data, a portion of data frames can be used for acknowledgement. This phenomenon is known as piggybacking. The piggybacking helps in better channel utilization. Further, multi-frame acknowledgement can be done. Sender sliding window, go back can. This one is receiver sliding window. Control variables. Popular ARQ protocol is the go back and ARQ, where the sender sends the frame continuously without waiting for acknowledgement. That is why it is also called as continuous ARQ. As the receiver receives the frame, it keeps on sending acknowledgements or negative acknowledgement. In case a frame is incorrectly received, when the sender receives a negative acknowledgement, it retransmits the frame in error plus all the succeeding frames as shown in figure. Hence the name of the protocol is go backend ARQ. If a frame is lost, the receiver sends negative acknowledgement after receiving the next frame. Now this figure showcases the normal operation of go back and. Now this one is go back and with the lost frame. Go back and sender window size. In go back and ARQ, the size of the sender window must be less than 2. The size of the receiver window is always 1. The selective repetitive ARQ scheme retransmits only those for which negative acknowledgements are received or for which timers has expired. This is the most efficient among the ARQ schemes, but the sender must be more complex so that it can send out of order frames. The receiver also must have storage space to store the post negative acknowledgement frames and processing power to reinsert frames in proper sequence. Here we have a selective repeat that it will gonna resend or retransmit only that particular frame of which there was an error. Selective repeat ARQ, the size of the sender and receiver window must be at most 1/2 of 2 raised power m. Now this is again selective repeat with a different window size. How the inefficiency of stop and wait protocol is overcome in sliding window protocol. The stop and wait protocol is inefficient when large number of small packets are sent by the transmitter, since the transmitter has to wait for the acknowledgement of an individual packet before sending the next one. This problem can be overcome by sliding window protocol. In sliding window protocol, multiple frames are sent before receiving an acknowledgement from the receiver. Now here we conclude. Flow control is the regulation of the sender's data so that receiver buffer does not become overwhelmed. Stop and wait, the sender sends a frame and waits for acknowledgement. In go back and selective repeat, multiple frames can be sent at the same time. SDLC is a protocol that implements ARQ mechanisms. Thanks for watching.